Hi, my name is Sam Tingaya. So, what I want to show you was I've been using Scratch for about 4 or 5 years, teaching students from especially K through actually grades 2 through 12, and it allows one to transition very easily. I mean, be able to learn programming without actually getting into the nitty gritty coding, but then you can get into the coding part of it because Scratch gives you that option. So, what I wanted to show you was how you can go from programming blocks and then from blocks go on to the actual like robots, coding robots and things like those. And then from there, actually going to the standard coding like C++ and then even beyond. But when you start with the grade two and things like those, the idea is to get them how to solve problems using blocks. And behind that is where you would see all of the different coding that is being done. And in order to get this done, it's pretty simple, simplistic. You can, if you go to MIT, scratch.mit.edu on your web browser, you'd end up getting this. You can also download the program, but the web browser is the easiest way. Majority of the time, you'll end up getting the screen that shows you different tutorials that others have created, and you could end up using that. I will close that so I can show you how this whole thing works. So what you have is on the left hand side you have what it says code, and these are all what is called category blocks. So these are different types of blocks that are available. At the current time you have the motion category block that is selected, and then within the motion category block you'll end up getting a palette of different blocks associated with motion. And then if you want to change this and then be able to take a look at the looks category block, if you click on that, now what it does is it'll show you all the different blocks palette of all the blocks associated with looks. You don't necessarily have to type on any of these. You can also use the scroll bar and then be able to go up or down, and it'll show you the control, it'll show you sensing and all of those. And if you bring it to the top, then it'll bring you back to the motion. And then within these tabs you have code, and then you also have costumes. You can take a look at some of those with respect to this is called the sprite that'll actually be doing all the different actions. And you can also use the sound. The first time I taught it, I used that. I've never used that again, because having a class of 20 or 30 kids and all of them decide they want to play some kind of a sound becomes a pretty massive distraction. So I have stayed away from using sounds, but sounds do have a lot of capabilities, all kinds of different instruments and things that can be played. So if somebody wants to learn how to do it in a productive, constructive way, that can be done too. So we have the category blocks, we have the palettes, and then this area over here is called the scripting area. This is where I would move my blocks, and then whatever the blocks I end up moving and I end up executing in my scripting area will be shown in the staging area. So this is your staging area. The scripts that you put will be displayed on your staging area. And this area over here is where your sprites are. And a nice part about this is it's not just one sprite that you can control. You actually get, in computer science they call it concurrency. I can have more than one sprite moving around, doing things, sensing if they're going to bump into each other, and so on. So you can get very creative, very artistic, very real life in terms of how you can end up programming it. So we'll try some very simple scripts to see how it works, and then we'll try and build a program up and then take it a little bit further and show you how you can use this on a robot. So here, the very simple one is your move 10 steps command. So I can click on this, drag it over here, let go. And then I'll just change this number over here. If I want to change this, I double click on this, the 10 gets highlighted. Then I would type in 20. And what that means over here is my sprite, or my cat in this case, is going to move positive 20 steps forward. And then if I click on this, you would see the cat move 20 steps forward. And of course, I can go and put a negative number over here and say negative 30. What that means is it is going to move 30 steps back. And then if I click on this, it'll move 30 steps back. Every time I click on this, it'll move 30 steps back. Every time if I want it to move forward, then I have 30 and I click on it, it'll keep moving 10 steps forward. So that is one way I can move it forward or backward. And then if I want to get rid of this block from the scripting area, I can right click on this and then say delete block. Or when I was teaching this, a second grader actually taught me how to do this. And I immediately went, yeah, of course I knew that. I didn't. They're just better at this thing and they were born with this. They're quick to figure out how to do this. They actually took the block and dragged it into the palette and let go and it disappeared. And it's much faster than the old-fashioned right click. Then I can get my turn 15 degrees. And what that means is this is at 0 and every time I click, it'll rotate 15 degrees at a time in a clockwise direction. And then if I want to move it counterclockwise, I will bring in the counterclockwise turn 15 degrees. If I click on it, it'll move in a counterclockwise direction. And one of the things about this is this is all working on an XY coordinate system. And I kind of try to teach them a little bit about the XY coordinate, but not too much because sometimes they might not catch it. So if you drag down a little bit to the palette, you can actually track, like a GPS system, you can track and see where the XY direction of the sprite is. So if I do a check on this, it'll show me at the current time it's on an XY coordinate system, this is at 10. X being at 10, and then if I click on this, Y is at 0, and direction it's at 90 degrees. And I can display these, and then what I can do is actually show, if I want to make it go to 0, 0, then I can try and see if I can drag it almost try and get it to 0, 0 type of a thing. That seems close enough. Oh, I got it. So it's at 0, 0 over here. And then what happens is if I bring in my blocks over here, and then every time I click on this, when it moves forward by 10 steps, it should automatically update the position. So it shows you it's moving along the X direction at 10 units. And then of course, if you put negative 10 and then click on it, it's showing you it is actually moving along the X coordinate, but in the negative direction. So this kind of helps understand, when the sprite is in the staging area, where exactly is it and what direction it's moving in. And then if you actually go and take the sprite and if you move it to these corners, you kind of get a general idea of what is the size of the staging area. So the right hand edge is at 214, 149 approximately. You can go up to about 160 on X, and then over here it's 230, negative 230, 152. So this can go up to about negative 230, negative 177. And then about negative 219 for X and negative 182. So it's floating around somewhere, the X can go up to about 280 plus minus, and the Y can go to about 180 plus minus. So that gives me a general idea of where I can move the sprite. Be careful, sometimes if it goes out of the staging area, it becomes a a little bit difficult to try and get it back. And one of the ways to get it back is if it goes too far off, is to go over here in the sprite area and put this at 0, 0 and hit enter and then try and get it back. You can also control the sprite from over here in case it goes out. The older versions of the program tended to do that. And then what I can do is I can use this go to X5 block. And then here I can say, well, I would like it to move it to 30 and negative 30. So those would be absolute values to which I would want the sprite to move. And then, so this can allow it to jump around. Another one is take this back over here. You can do this glide, just kind of instead of it being kind of a random movement, I can come up over here and say, I would like it to glide to this position. You can change this too, of course. And then if I click on this, it's currently at that position. So let me get it over here and then say glide. And then you'll actually see it glide to that position. So that is how these blocks ends up working. And there's a whole bunch of them that you could end up using to control how this is going to work. And one of the things to immediately teach is you don't necessarily want to keep clicking on this to get it to the sprite to do things. You want it to like run it like a program. So what you can do is, I'll move the sprite over here. And instead of clicking on this, you could end up going to events. And under events, you have this block called when the green flag is clicked. And what you will notice in the events is it can only be plugged in one way. This can actually, if you look at this block, I can plug in one block from the top, and then I can also plug in another block from the bottom. Here, this can only go in one way. So if I want to plug two blocks together, I would take this, and as I move over here and let go, now they are one. What this allows me to do is now instead of having to click this to control the sprite, I can control it using this green flag over here. So once I've done this, any block that has a green flag will automatically get executed. Now when I click on this green flag, it does the same thing as having clicked this block. This is a much better way to do this because I can add in a whole bunch of blocks and then be able to just click on the green flag and it'll execute that entire block. And if you run into what is called an infinite loop, that is, it just keeps executing things and doesn't stop, you can end up doing the stop over here by clicking on the red one. And that allows the program to stop. So initially when you want to teach students how to do this, you just want to start with the motion and then be able to show a few of how these work. And then try and show them how to control it using the green and red colored blocks itself. And once you've gotten to that point, there's also a couple of other things you can teach them, that is things like looks. So what I would like it to do is I would like it to glide from wherever it is. And once it's done gliding, I would like it to say hello for 2 seconds. So I would take this block, plug it underneath. So now what this means is the sequence of steps, which is what a program is. I have a problem, I come up with a sequence of steps. I would like it to glide to -178, -123, x and y coordinates, and then say hello. And then when I click on this, it'll glide, and then for 2 seconds it would say hello. And it doesn't necessarily have to say hello. You could actually change this and say yabba dabba do, and you would like it for 5 seconds. And then move this up over here. So you can actually have it do things and then be able to, be able to interact also. The say basically, it's almost like it's speaking. The thinking part is as if it's thinking about it. So I can bring this over here. And then if I click on the green flag, now it's not actually communicating, but it's actually thinking to itself, and you can of course switch these two. So this would be a starting point on how to teach Scratch, is show some of the things that you can do with motion, show them some of the things that you can do with looks, then definitely show them how to do the start and ending part of it with the blocks, and then get them started with it. And then usually what you would see is I've been doing these types of workshops and summer camps and so on. And you have to kind of step back a little bit and let loose. And the kids will just take off on their own. They want to do different things. They're going to go in different directions. I give them about 5 minutes to go and do that. Then I got to bring them back in and say, okay, this is all fun and nice, but you still have to learn a whole lot more to be able to do better things. So I just let them go, wait for about 5 minutes. After they're all done, bring them back and then show them a real example of something that you can build that is extremely creative and constructive. And I'll continue with that part of it after this. The second part I want to show you is how to go about drawing, for example, a simple box. And then we'll try and expand on the box. And usually whenever I teach that, I get them started initially on how to draw a line, go to a box, go to a hexagon, and then be able to do colorful things with it. The box, in order to draw anything, you need the pen, and the pen doesn't show up by default in the category block. So if you click on the plus sign here, and then draw with your sprites, you click on that, then you will notice you'll end up getting the pen. And the most important commands in the pen is the pen up and pen down. So if the pen is up and you're moving around, it's not going to draw anything. If the pen is down and you're moving the sprite, then it'll draw lines or squigglies or whatever you would like. So the first step that I would like to get my when clicked control, and then under pen, one of the important thing is whatever has been drawn before, I would like it to be deleted. So I would like to put an erase all, and then I would like to select a pen color, and then you can click on this color area over here and then select whichever color that you would want. So I'll just go with sort of a purple at the current time. And then I would like a pen down so that whenever the sprite moves, the sprite over here to give it space to actually draw the box. And then what I want it to do is get move steps, and say I would like it to move 100 steps. And then if I do this and if I click on it, then what it'll do is when the pen is down, when it moves 100 steps, you'll see a straight line being drawn from its current position to, on the x-axis, it'll move 100 units away. And then if I click on the green flag, so that drew one straight line. So what I would like you to do is, I would like you to do 100 steps, then I would like you to rotate 90 degrees, draw another 100 steps, another line, rotate 90 degrees, draw another line, and if it does this 3 more times, then you're going to end up with a square. So we can accomplish that by putting turn degrees change this to 90, then I'm going to get it back and then have it run. But all it does is it goes and then just turns. After it turns, it has to move 100 units in the y-axis. So put this over here and say do 100, and I think what I also have to do is glide, actually have it point in 90, because whenever it starts I want to make sure it's facing in a 90 degree, otherwise it's going to do some funny things. So what I can do is, even if I have a set of blocks over here, if I drag it at the bottom I get one out. If I drag it at the top I would get all of them out. So what I did is drag this out, make sure it's upright. Then I want you to move 100 units, turn positive, turn clockwise 90 degrees, and then do another 100 units. And then now if I click it, so it was upright, moved 100 units, took a 90 degree turn, and then did another 100 units. So one of the other things you can do is I can pull this, right click it, and say duplicate, and it'll give me two more of the same thing. And then I can add it over here. Now when I run it, it'll give me a square. It'll give me 3 lines. I'll get this back over here because otherwise it'll keep drifting down. And then I want to take this back again and say duplicate this again. And then of course clear all will clear everything, and then when I click on this, let me get my sprite back here, and then if I click on it, what it does is it clears all of the graphics. It moves 100 units, does a 90 degree turn, 100 units, does a 90 degree turn, moves 100 units, then does a 90 degree turn. I would like it to be upright when it gets over here, so I'll add another, either I can do that, or I can just say point in direction of 90 when you're done doing the entire box. And then if you really wanted to see how this was happening, what you can do is you can put a delay of, let's say, 1 second between each of the set of moves, so it doesn't go so fast that you cannot see it. And now if I run it, you'll notice it will stop 1 second at each of these points as it rotates and draws a line. First, second, third, and then fourth. So one of the things you'll notice is, if I want to do even further, I'm repeating the same set of commands again and again. So in computer science, if I needed to repeat the same set of commands again and again, I would end up using what is called a loop. You'll notice it's move 100 steps, wait 1 second, rotate 90. Move 100 steps, wait 1 second, rotate 90. What I could do is say, well, this is being repeated. So if it's being repeated, is there some way that I can kind of put this into a loop? So I'll dismantle all of this, and then these are the 3 steps that I want to run, and I want to make sure that the cat is upright when it starts, and I want to make sure the cat is, or the sprite is upright when it's done. We'll put all these away. And then what I can do is go and get one of these repeat or loops. and take this loop, and I would like it to run 4 times. And I will take this whole thing and slide it in, and you notice when I'm going to slide it in, it goes from white to gray, and connect all these blocks. So now what it's saying is, make sure the sprite is upright, make sure that it does these steps, 3 steps 4 times. When it gets done, it'll once again be upright. So I didn't have to repeat the same set of commands again and again. And when I run this, I should end up getting the same result I had when I had all those other 4 set of things, commands that were being repeated. And then if I run this now, just move this up over here, run it again. So as soon as it starts, kind of doing it a little bit different. Let me see if I can get the same action as before, which is move 100 steps and rotate by 90 and then wait 1 second. Now I should see it move straight down this way, rotate, and then come up. So it ends up doing the same thing, but I'm able to now use a loop. And loops are very powerful constructs when you're programming. So what I can do now is do something like a hexagon. And the hexagon I want is basically, I want it to loop 6 times. But then I don't want it to do a 90 degree, because then what will happen is it'll just end up doing a square and repeating 2 more lines. I want it to rotate by 60 degrees. So if I change this to 60, and now when I run it, I would end up getting a hexagon, because it goes up over here. Instead of a 90, it does a 60, then it does another 60 and another 60, and then ends up doing this 6 times. Now, if you want to make this a little bit more interesting, what you can do is go to the color part of it and say, you know what, every time you draw a line, I would like you to change the color of the pen. By 10. So the number for the color can, I think, go from between 0 and 255, and so this will kind of float around the same, but if you want, you can increase this to 20. So every time it draws a line, it will end up changing the color. And then if you run this, you would actually see that different color lines are actually being drawn. The really nice part about this is now you can, what if I actually have this doing this multiple times and then just keep shifting it a little bit, and you'll end up getting a very nice design. But what I would like to do is, I would like to do what is called a nested loop. So I can have a loop inside of a loop. So let's do this. So I have a repeat. So I would like it to repeat the outer loop 72 times, the inner loop 6 times. So the 6 times is actually the one that is going to give me the hexagon. So this, the inner loop, is going to draw a hexagon, and then when I come out of this, I'm going to end up getting 72 different hexagons. But if I left it as it is, it'll just end up doing the same thing again and again over the same one. So I need to shift it a little bit and then change the color. So what I do is I'll change the color of the pen once the hexagon is drawn. And then also what I want to do is I just want to turn it by 5 degrees clockwise. So it's not drawing over the same hexagon, it is going to shift a little bit and then rotate off of, so you're going to have a displacement of about 5 degrees. And then I'll keep this in here so you can actually see what is going on, and then I'll take it off and then you'll see the design pattern. And now if I run it, you will see as it's drawing each hexagon, it actually starts shifting by 5 degrees, and because you have the shift in 5 degrees, you'll end up getting this nice pattern, and each hexagon of course is being drawn in a different color. And usually when I'm teaching it, after I do the hexagon, the students are off and running on their own, and I kind of throw this design pattern on the wall and they go, ooh, and they would like to do it, and I have to tell them, oh, if you've been listening, or if you will continue to listen, then you can do some interesting things. And then they would of course start listening, I show them how to do the nested loop, and then I'm back on track with them. But that's the interesting part about the whole programming thing. You take simple steps like loops, you take simple moves, and then you have turn by 5 degrees. So all I've done is taken one hexagon, just shifted it by 5 degrees, changed the color, and said, run this through 72 times, and I end up getting a new design pattern. So what you will end up realizing is all this time you've actually learned how to program without really programming. All you've done is just taken a set of blocks, put together, and then run it. But when you're doing this, you've learned the important concepts of how a pen works, how an assignment works. So when I go in and put a number into this, in normal computer programming, these become variables that hold the numbers. And I've also learned how to do a loop, and I've also learned how to do a nested loop. But all of these were like kind of in the background. You're learning all this because you're having more fun doing the things that the cat is doing and then seeing how I can put these blocks in. So programming is about problem solving, not computer programming. So you can solve the problem either using Scratch or C++. I start them with Scratch and then move them towards C++. The whole idea of computer science is the problem solving part. And Scratch ends up being a really good type of an environment where you can teach students how to program without them literally having to fight with the whole syntax and everything of C++. And the next one I want to show you is how you can take what you have learned from Scratch and then be able to program a robot. The next set of programs that we want to show you has to do with how to go about using Scratch or Scratch-like environment to program the mBot make block robot. And what I have here on the display is you can buy this on Amazon. Actually, when I started purchasing it, it was somewhere around the $80 range, and looks like they're on discount at the current time. So it's actually dropped down to about $56. And the robot comes with, if it'll let me, so it comes with 2 different sensors. So this is your sonar sensor, and that's your light sensor. And it has a Arduino board at the top. It actually comes in, basically you have to assemble it together. It takes about 20 minutes to be able to assemble it. So what I'll do is I'll show you an assembled version of it, how to connect it, turn it on and off, and then how to write a program, download it onto the robot, and then actually run it. And you can add other sensors to that too, and then be able to do all kinds of different tasks. And I've tested this out with kids from grades 2 onwards, and this is a whole lot better than the Lego robots because they're actually made out of steel plates, and you can actually, you have to kind of use nuts and bolts, and that helps the way students and kids handle the robots. The Lego robots, the parts used to come off pretty quickly. This one is pretty solid, stays intact, even if there's some kind of a rough use. But of course, you definitely do not want to drop this on the floor, and that has happened too, and that usually ends up, a couple of them actually just flattened out the sonar robots when they dropped it. So I'll show you what an assembled one looks like and then how to go about programming. So this is what the assembled robot looks like, and then it has a sonar, and then it has the line follower sensor, and I've attached, this is about like $5 for which you can get this. It's like an LED to show you a program that can do emojis and things like those. And then I've also attached another like digital number that you can show within the time limit that I have. I'll try and show you it, as many as I can. Uh, each program can do very different things. And then the two critical things with the robot is this is your on-off switch. Extremely critical. Over here, if you see, there's a button. And the reason you need to know this is as soon as you download the program, the robot just will start moving. And if it's on a desk or something, you could end up falling. So what you have to do is when you're programming, I'll show you where you have to put this condition saying only when this button is pressed should the robot actually start moving. That way what it does is it gives us time to download the program, unplug the USB, put it on the floor and hit the button. And I've seen students do it, they just, if you do it without this, it'll fall right off the desk and it'll damage the robot. And then I have a USB that is connected to the computer system, and I can write a program, download it, and then hit this and tell it to execute the program. And I'll show you how to do a couple of these programs. The mBot robot actually runs on an environment very similar to Scratch. So it's not the MIT Scratch that can be used to program it. So if you go to worldwideweb.makeblock.com, and there they tell you all the different kinds of robots and accessories they end up building for it. And then if you click on software, you would see the Make mBot comes up. And if you click on the mBot, here you would be able to go in and download. The program is free of charge. You'll be able to download the Scratch-like environment that you would end up using to be able to program the mBot. So I have downloaded it, and then I'll show you how to go about programming it for the mBot robot. So once you have the mBot environment set up and you click on it twice, you would end up with this display, which is very similar to Scratch. They tend to use the same type of blocks and the way the coding should be done in Scratch, but it works for the robot. A couple of things are extremely critical to ensure that you program the robot correctly. The first thing is over here. Right now by default it shows Cody, which is a different kind of a robot. We need to add the mBot to it, so I would say plus, and then I would go, there are different robots that the company supports, and all of them are, I wish I had the time to go through all of them, but each one of them has their advantages on what they can teach, mBot being the easiest one to start with. Cody is another one too that you could start with. So I would click on mBot and then click on OK. And then mBot should show up over here. And this should be displayed or highlighted as you're programming it. The second part is you would connect your mBot robot to the computer system, and then you need to click on this connect button. And when you do that, what it does, it'll automatically figure out the communication or the COM port and say, this is fine, leave it at the default, click on connect, and then you should get this message over here saying connected, and also you should get this message over here saying, disconnect or update. One of the not so nice things about the robot is it continuously wants to keep updating the firmware and so on. So if this shows up, click on this and say update firmware, just leave everything at default, and then say updates, and it should go pretty quickly and update the firmware for the robot so that it has the latest firmware. And once that is done, we can start learning to, so once it says it's finished, click on OK. So the update firmware goes away. You'll have to do a connect again once the update is done. And now we have the robot and everything connected, and we can start programming with it. There are two different modes in which you can run the robot. One is the robot is connected to the computer system, which means the USB is still connected to it. The other one is I can download it, unplug the USB, and then run it. So let me start with the first one, which is the robot stays connected to the computer system. And what I want to do is just have it basically just blink the green light on the robot multiple times. So to do that, I will do the same thing that I did with the original Scratch program. I'll have the green flag when clicked, and then I will go to control. I will do a repeat 10 times. I would like the green light to repeat 10 times. And the LED lights can be found under show. So there are 3 different LED lights, but we will blink all of them. So I'll put that in over here. And then I would like to have a different color than red. I will say green. And then I'll also put a delay saying blink. And then wait for 1 second and blink again. Wait for 1 second. Actually, it already has a second. I'll leave that anyway. That means there'll be a 2-second delay between these. And then once this is collected, what I can do is just go and click on this, and the robot should blink the green light 10 times with 2-second delay between them. So I will click on this, and then I will show you what happens with the robot. So you would end up getting this yellow outline indicating that it's blinking. And then I'll stop this, go back, switch it over to the camera, and then show you what happens with the robot. So same program with the robot connected. If I click on the green arrow, green flag, and then I switch over to the camera, you would see the robot will now blink with a 2-second delay the green light 10 times. So that's one of the simplest of programs we can write. So the second way to do this is I want to kind of remove the connection from the robot and then have it run without it being connected to the computer system. In order to do that, if you click on events, you will see this robot MCO starts up is grayed out, but the others are on. So what that means is, except for the grayed out commands, all of the other commands will work as long as I have the computer connected to the robot. So to upload it, remove the connection, and then run it, what I need to do is first, let me dislodge this, and then I need to click on this upload mode. And if I click on this upload mode, you would see it says upload over here. Now what you will notice is the mBot MCO starts up is not grayed out and all of the others are. And clicking the flag only works when the robot is connected to the computer system. So I will put this away, and then what I'll do is I would want to run it when I upload it. But you have to be careful with this. As soon as I upload it, this command says just start executing. So if the robot was supposed to move and it's sitting on a desk, and you do this, as soon as you upload it, immediately it will start moving. Especially with kids, when you try to do that, the robot's going to fall off the desk and it's going to damage it. So what you want to do is put a condition and say move it when that button is pressed. And to indicate which button that is, remember we said there's this black button over here. When we press that black button is when we would like the robot to actually move. So in order to do that, you would go into control and you will put in a wait until condition. And in order to indicate you have to press the black button, you would go into sensing. And then there is this when onboard button press, and there is this hexagon over here. I would put it in. Now it says when the robot starts up, it's going to wait until you press the black button, then I'm going to run the code. Now take this whole thing, put it as a block, and now once I have the program, what I can do is click on upload, which means upload it to the robot. And when I do that, you'll see a bunch of code followed by a progress bar. It'll come and say the code has been uploaded, which means it's all good. Now what I can do is switch over to the robot, and then what I can do over here is I will remove the USB connection. I don't need it anymore. So it is not connected to the computer, and then when I click on this black button, the program that I uploaded onto the memory of the robot will start executing. So that's as easy as how you would actually program the robot. It is still Scratch. You do the Scratch and then put it onto the robot and just tell it to execute. Now I'll show you one more program on how to just make it move or do something very simple, like move 10 forward. We did that move forward 10 steps and the sprite actually did it. Now instead of the sprite, we'll make the robot do that. So we just looked at how to go about programming it without the robot being connected to the computer, where you can upload it and then run it. One of the mistakes I keep making on a regular basis is once that happens, I forget to connect my robot back on. So what I need to do is I need to go back, connect the robot back on, and then switch over to mBot and then click on connect and make sure it has a connection. And it'll go through the same process again. Just say connect. And once it's all done, we're good with that. And what I want to do is now show the last example, and there's a whole bunch of things you can do with power and making it do an M and N and L and sonars and so on based on the time limit. I'll show you one last example where what I wanted to do is just move forward for a few seconds, and then it's pretty straightforward. The very critical thing is keep these two commands So this is my block. I can take this away. Always keep these two commands at the top of anything that you do when the robot is not connected to the computer, so that you don't damage it. So when it starts up, it has to wait until you press the black button. And then I will remove this and then take the move forward at 50% power. So that power controls the speed. And then let's see if we can get it to go 2 seconds without falling off the desk. And then once that's done, what I can do is say upload my program. I will go through the upload process. Tells me it's been uploaded. So now what I can do is switch over to my camera and then remove this. I'm actually going to have it go towards the camera without, I'd have to just grab it in case it's going to go slam into it. And when I click the black button, it'll move for 2 seconds. I can do this any number of times I want because the program is actually being loaded into this robot. Turn it off, turn it on. So that is how you actually make it move forward. I want to show you one more last one, which kind of keeps the kids interested and kind of gets them all excited about it. And that's basically the display over here, and it's a pixel display, and you can do all kinds of interesting things with it. It costs about, I think, about $7, and then it's actually mapped to under looks where it says LED panel, and you can do all these different things. One of the things to notice is your robot actually ends up, it has about 4 different ports. So port 1, port 2, port 3, port 4. So what that indicates is how many different sensors you can connect. So right now the sonar is connected on port 2. The display is connected to port 4. So you've got to keep that in mind as you're programming it. And what you can do is, if you go to the display over here, and what I would like to do is just show these eyes for about 1 second, but to make sure that you can really see it happening, I'll go to the control and say run through this 10 times and show the eye for about 1 second. So you'll see these eyes blinking for about 1 second, 10 different times. And then this is at the current time, the robot's connected to the computer. And then what I'll do is, if I click on this and then go over to the camera, you should see the eyes blinking 10 times. Oh, something. Oh, I'm sorry. I need to put that to port 4. I just mentioned that and I didn't do that. Put it to port 4. Click on this, and then if you go, you would see these eyes blinking 10 different times for about 1 second. And the interesting part about this is you can actually go into this, and then you can come up with different designs that you want to display on it. And this is where the creativity of the students comes into play. And then you can give it, let's say, this look. Say, okay, I want to go with that. And now if I go and click on the green button, switch over the camera, I would get a different look. So you can do different kinds of, and they can do any kind of a design they want using these. So I can actually go in and say edit, and then erase some out and come up with my own designs. And I'm not a very artistic, creative person, so I'll leave it up to somebody who is to do these designs. So you have these number of pixels, 8 by 16 pixels, and you can come up with different. So in addition, after this, what happens if you still want to continue learning about C programming and things like those, the blocks actually just generate code in the background. So you can go and click on Arduino C. What is that? I can do it from here to. So if you notice over here, there's less than, greater than sign. If I click on this, it'll actually show me the code that is being generated for these blocks. So it's all being done in the C language in the background. So let's say grades 2 through 6, you can still teach them how to use blocks in Scratch. And as you start moving towards grades 7 through 12 or 8 through 12, now you can start telling them, look, these blocks generate this code, so in order for me to get these to work the way it is, this is my actual code I would end up writing in Arduino C. And now you have shifted them over from actual block program to computer programming, which ends up being used in college. So you can use Scratch, the robot, and then C programming right through from grades 2 onwards, so grade 12. So that concludes my presentation, and it's been a pleasure explaining how this works. I've been doing this for a few years. I'm hoping to start a master's program in this, in computer science education, and get more teachers involved. By all means, if you have any questions or you would like any help or demos or anything of that kind, please contact me and I'll be happy to help. Thank you, and it's been a pleasure. Take care.